Hi there. I wanted to show an example of using the audio sniffer to debug a x0x box. The audio sniffer is great because it has a high impedance input. Basically it's like an oscilloscope in and a headphone amplifier out. So it doesn't affect what's going on inside of the circuit when you're listening to the circuit. So you just clip on the ground, and let's take a look at the waveform switch, which is a common place to look when you're seeing if the VCO has been built correctly. And signal. Right level. Alright, great. Signal's coming in. There's a square wave. There's a saw wave. Now, just to show exactly why that's useful, is let's do the usual headphone test, which is you clip ground, and then you find another ground point in the circuit, and you clip to that. And now let's listen what happens. So, here we are on the square wave. Oh, guess we don't get to hear a square wave anymore. We don't get to hear a saw wave either. Basically, the headphone is loading down the circuit and making it so that the signal goes away, which is what's nice about the audio sniffer. The signal still stays there. A lot of people look over at R62, which is right where the signal goes into the VCF. And on one side you have signal, and then they look on the other side and there's nothing. You actually still have signal there. It's just really quiet. The audio sniffer lets you amplify and listen to that. Let's do a whole bunch of other things as well. If you want to listen to digital data, that's the sound of the switch latches being scanned. There's a nice little shimmer in there. If you want to listen to notes getting triggered, this is kind of a quiet one, but you can hear the rising and falling edges of the gate signal. Along with any other, you could listen to the MIDI data going by, you can listen to the VCF, and what makes it particularly useful is these scope probes that you can get with it have a divide by 10. So the signals on here are can be plus or minus 2.5, 3 volts, and this will drop that down into a more reasonable range for sending into a sound card, which is another way you might want to use this. You can capture all these signals on your sound card and take a look at them and have a much better representation than you'd get if you just connected your sound card directly up to the board.